Welcome to this video on the world of metals and nonmetals, a field guide to the essential elements that have built our civilization. Metals are typically lustrous and hard, like iron or copper. Nonmetals, such as wood or sulfur, are usually dull and brittle. However, there are anomalies. Mercury is a liquid at room temperature, while sodium and potassium are soft enough to slice. Malleability is the ability of a material to be beaten into thin sheets without fracturing. Metals like gold and silver excel at this, which is why we use them for thin foils and food wrapping, whereas brittle materials simply shatter under impact. Ductility describes a material's capacity to be drawn into thin wires. Gold is incredibly ductile. A single gram can be drawn into a wire 2 kilometers long. While nonmetals cannot be drawn this way, we use metal alloys like steel for high-tension cables. Sonority is the ability of a material to produce a sustained, ringing sound upon impact. Metals are generally sonorous, which is why they are used for bells and chimes, while nonmetals tend to produce a dull sound due to energy absorption. Metals are excellent conductors of both heat and electricity. This makes them ideal for cooking utensils and wiring. Conversely, nonmetals act as insulators, protecting us from thermal and electrical hazards. This matrix summarizes our findings. Metals consistently display luster, hardness, malleability, ductility, and conductivity, distinguishing them clearly from nonmetals, which lack these collective physical properties. Historically, early civilizations mastered copper and gold for ornamentation. However, it was the transition to iron, with its superior hardness and strength, that truly enabled the creation of advanced tools, fueling the agricultural revolution. Despite their strength, metals are vulnerable to corrosion, a process of gradual deterioration caused by the environment. Examples include rust on iron, green coatings on copper, and tarnishing on silver. In this experiment, we seek to identify the exact conditions required for iron to rust by testing different environments, specifically focusing on the presence of moisture and air. We isolated our variables using 3 bottles. Bottle A contains dry air, Bottle B contains boiled water sealed with oil, and Bottle C leaves the iron exposed to both air and water. The results are clear. Rust only occurred in Bottle C. This proves that the corrosion of iron requires the simultaneous presence of both oxygen and moisture. To protect iron, we must prevent it from contacting moist air. Common methods include applying a chemical coat like oil or paint, or using galvanization, which bonds a protective layer of zinc onto the metal. The Iron Pillar of Delhi stands as a testament to ancient metallurgical skill, resisting rust for centuries. It serves as a reminder that understanding the properties of materials is the true foundation of human progress.